All right, for today's lecture, we have quite a few different topics. We're going to be talking about measurement, we're going to be talking a little bit about validity, and we're going to try to tie all those things together by the end. So we're going to start with measurement, and measurement's kind of it is the foundation of how psychology is built and how our research is built. If we don't have good measurement, we don't have a good study. So we need solid measurement in order to build a good study. So measurement's also important for what type of statistics we use. You know, if we're using some sort of Likert scale, a continuous scale, some sort of dichotomous scale, that changes the statistics we'll use too. So we'll kind of highlight that as an important for picking statistics. It's most important though for building the foundation of our research. So when we measure, again, we talked about this with, we were talking about diversity in our sampling, but also we need to think about measurement and who we're sampling and how the measurement might be different for different people. So a lot of times measurement's created with a college sample. Hopefully it's taken further than that and normed with the group that you're wanting to norm it with. But a lot of times it started with a college sample, and we think of a Western society college sample may not be the same as everyone else. So if we think of a construct like social anxiety, in Japan, social anxiety has an additional component of the worry about embarrassing others as well, embarrassing yourself, but also causing somebody else to have a redness in their face would be something very bad. So when we think of that construct, we want to make sure we measure it the same for each culture, and we get the different components for each culture. So one of the important things to memorize or to think about for measurement is what's called the nominal, ordinal, interval, and ratio scales of measurement. And each one of these scales of measurement adds a different level of complexity to it. So we'll have different ways of measuring things, and we'll assign them on these scales. And this is really going to be important for which statistic you use. So the first is the nominal scale of measurement. And nominal scale of measurement is just giving people a number. So your student ID number would be an example of a nominal ordinal of measurement. It's just an assigned number. Higher or lower number doesn't mean anything. It just it gives you an ID number. So the nominal just names you. Ordinal takes it up one level, and it puts a ranking on the number. So a lower number is a higher ranking than a higher number. So we think of movies, it's the number one movie in the country, the number two movie in the country. It gives a ranking system. It doesn't tell us how much better the number one movie was than the number two. We just know it was made more money than the number two movie. So it's that ranking system. It just tells us the rank. It could be the number one movie made 8 times as much as the number two movie, or it could be just it made a slight amount more than the number two movie. The ordinal scale just tells us which one was number one, which one was number two. So in order to get at how much more, we have to get to the next level, which is the interval scale of measurement. And interval assumes that all steps between the numbers are exactly equal. And I'm going to lump interval in with ratio because for our statistics, we're going to lump these two together. So ratio just has an absolute 0 point. Interval doesn't have that, but they're similar otherwise. So interval and ratio scales tell us how much of a difference. So somebody who has a score twice as much, we know, or 2 times as much. Somebody who, I have a 20 on my anxiety measure, and you have a 10, I have twice as much anxiety as you do if it's on a linear scale. So we know each point is exactly the equal amount distance between the two. So those are interval and ratio scales, and again, I'll lump those two together. Especially on the quiz, I'll lump those two together, but they're together because of statistically we treat them the same. So when we are looking at our measurement, we want reliability in our measurement. So we want to measure the same thing every time. So if we've got I've got here a scale to measure weight, and I'm thinking of an old type mechanical scale, but if there's a slight screw that's loose, that could affect things, or if it's an electronic scale, if something's going wrong with the software and it was unreliable, that's not a good scale for measurement. We want the same measure every time. So when we think about reliability, I think of it as this type of an equation. So what we measure is our score that we measure. There's some error to that, but there's also a true score. And let me actually show you in a diagram, and I think the diagram makes it a little bit easier. So this is the equation that I think of. So we have our x, which is what we get, our measurement. So let's say if we're measuring depression, this is the Beck Depression Inventory. This is what we observe. Their score is X. That X is made up of two components. One component is the true score, their real amount of depression, and the other component is the error, the part that's not their depression, that's unrelated to their true depression, but it's just there. So for example, an item on the Beck Depression Inventory gets at fatigue, and that could be related to depression, but it also could be error. A person could be tired for many reasons. So when we look at that score of X, we need to know that it's made up of a true score and the amount of error. The more reliable the measure is, the smaller the error will be. So there's 4 ways that we measure reliability. So I'm going to go through each of these. The first one is test-retest reliability. So this is commonly done. We give the test once, and then we give it again. And how similar their scores are, get at how reliable the measure is. So we usually use a correlation coefficient. We look at how correlated the two measures are, the 2 time points are, and we think of this as our reliability. So when we think of that equation, that true score plus error, we also have to add in change when we do test-retest reliability. So something like depression, my depression this week, and then I take the test again next week, might have changed. And that's not part of the error. I mean, we often assume it's part of the error, but it's just me changing. It's not error in the measurement, it's me changing. It's not part of the true score because it's my change in depression. So when we think of test-retest reliability, we also have to look at how long of a distance there were between the test intervals. We also have to look at how stable a measure is. Something like a personality trait is thought to be more stable and doesn't change over time. Something like mood or anxiety is thought to change a little bit more over time. So we want to make sure that the test-retest interval is associated with how much change we'd expect and try to minimize that change because we're really just trying to get at the reliability of that measure. So one way we could do that is just take the same test and split it in half and look at how the first half relates to the second half. Tests like the personality test, the MMPI, they give the same questions in the first half and then the second half, and they look at how your response is similar. And in this situation with the MMPI, they're looking at how reliable you are as an individual, but we could do the same thing with a test. We could give the first half of the test, second half of the test, and look at split half reliability. This is not done as often. There's some other types of statistics that can be used to look at, instead of just first half, second half, just looking at how each item correlates with each other. We'll get into more detail of that, but just an overall test reliability, we can look at split half. One note, the Beck Depression Inventory, the first side of the paper test, if you're doing it by paper, gets at more cognitive related symptoms. The second side gets at more vegetative, like sleep, fatigue, appetite. So when we look at first half versus second half, we might not think they're going to be exactly the same. So that's something else to consider. Do we think the first half and second half should be the same, or should we use a more complicated statistic when we look at split half reliability? Alternate form, again, is not used as much as test-retest, but when we have like a math test, we could do an alternate form that has items that are the same level of complexity, and we just look at how these two alternate forms relate to each other. So this is another way we could look at reliability, these alternate forms. And things like memory test. We can't give the same memory test over and over again. We'll have to have alternate forms. So there are some specialized tests where there are alternate forms. Inter-rater reliability is when we're rating things. Of course, that's in the definition, but if we're rating behaviors, we want to make sure that the two raters get the same type of rating. So, or we're assessing a diagnosis. In one of my past postdocs, I had to watch tapes of diagnostic interviews, and then I would have to say what I thought the diagnosis was based on the interview, and that would be compared to what the interviewer thought the diagnoses were. So we were looking at inter-rater reliability of diagnoses. And then, so we were talking about reliability, and this is just how the test measures the same thing, gets you the same score every time. But we also talked about accuracy before, and that gets at validity. Does it measure what we want to get at? So the dartboard that's in your textbook, I can hit the same spot every time I throw the dart. It could be missing the dartboard completely. And I'd be really reliable missing the dartboard, but it's not accurate. It doesn't have validity. So we want to make sure we have both the reliability component, but also that validity component. And we need reliability before we can have validity. So again, that basis of reliability is needed before we can have a valid test. So we talked about internal validity in the last lecture, and we had the big 10 confounds of internal validity. That gets at, does our IV get at the outcome? Is our IV responsible for that outcome? So we've talked about that one already. External validity gets at, do our results generalize to other people, other places, other times? So an article from 20 years ago may not apply to today, and so we have to look at, does it have external validity to today's time? Does this sample that we had with of people from the United States, does this generalize to people from someplace else? So when we're looking at external validity, we're looking at, do our results apply to other people? And we have many threats to external validity. I'm going to kind of go through some of these quickly because I don't want to confuse the threats to internal validity. But something, with sometimes the threats to internal validity also cause threats to external validity. So let me go right on to this next one, the experimental arrangements. So quite often when they're testing, right now they're doing vaccine trials, or when they're testing a new statin medication for cholesterol, or those type of things, you go into a clinical setting and it's very different than how people might take the medication at home. So if I'm taking a brand new statin medication, they're going to draw my blood, they're going to do all these things, they're going to ask about my diet, they're going to ask me about side effects. So before I go into that next appointment, I'm thinking about all these things. And maybe that day before the appointment, I'm going to start eating a healthier meal because I know tomorrow I'm going to get my blood work done and all of these things. So that experimental condition is maybe very different than what it's like when the person is at home taking the medication. They're not thinking about all of these other things that are going to happen in that clinical setting where the drug was tested. So something about that experimental arrangement where you're going into a lab and getting all these things done is very different than what you experience outside of that experimental setting. So we've talked about these other things, the just being assessed, that's kind of related to what I was just talking about, but being tracked can change behaviors. So if you enter a weight loss study, you might think about changing your behaviors even more than if you're trying just to apply it on your own. All right, so the third type of validity is construct validity, and this one really relates to measurement. Because with construct validity, how well does our measurement get at the construct we're trying to get at? So we might be looking at things that carry some more terms that may not be as important to memorize, but convergent validity versus discriminant validity. So let's say we create a brand new anxiety measure. we want to make sure that anxiety measure converges on existing anxiety measures, that it's related to already existing measures. But we want to make sure it discriminates from other measures of other constructs. So we don't want it to measure depression, or we don't want it to measure just negative affect. So we want both convergent, converges on other measures of that same construct, but also divergent, being differentiating from other diagnoses or other constructs. So when we're looking at construct validity, we want to make sure our measure gets at that construct we're interested in. Those are just two other ways to look at it. The textbook lists this very complicated definition of construct validity, but again, I think of it, does our measure get at what we're trying to measure? So when we're trying to measure something like aggression in an experimental setting, that's a tough one to get at. How do we measure aggression without having people get into fistfights? Or how do we measure aggression like we would with road rage or those type of things? So in an experimental setting, we have to make sure that we can get at that construct, and aggression's a tough one to get at. Some studies have used things like adding hot sauce to somebody else's food or drink. And that's one way to look at aggression. But is that the same as other types of aggression? So does that have construct validity? So when we want to improve our construct validity, we'll make sure we operationally define what we're looking at. Something like self-esteem is, we have a pretty good definition, but how do we operationally define that so everybody would think of it exactly the same? And that can be a difficult thing to do. So we want to make sure that we get at a good operational definition and we're defining and labeling our terms really well. So I got this article from 1999. I know it's an old article, but this is Schwartz's life work, and he talks about self-reports. In this article, I've been wanting to find a new one, but it just gets at how self-reports and how creating self-reports can go wrong so well that I just keep this example in here. So Schwartz found that when you ask kids, or when you ask parents, what's the most important thing for children to prepare them for life? If you leave it open-ended, you get very different responses than if you ask them a question like this. It's the same question, and if you ask them to think for themselves, get a good education, have a loving family. I added the eat more peas in there, just it's not a very funny joke, but just, when we're thinking about it, when we give a closed-ended question, people will respond very differently. And so what Schwartz found, that 61% of the samples said to think for themselves. Yet when they were given the open-ended question, only 4.6% of people said to think for themselves. So again, those closed-ended questions can really change from 61.5% of people saying to think for themselves when it's given as an option versus only 4.6% when it's an open-ended question. So very different responses, and that's kind of a scary thing, like to think that we get very different responses based on just how we asked a question. Similarly, if we ask this question, how successful have you been in life from 0 to 10, versus the same exact question, but we change the scale from -5 to 5. And what Schwartz found and other colleagues have found is that people don't put a negative answer. The scale changes completely for them, so they're putting something from 0 to 5. We've just limited their range, so their actual number, 34% gave a number between 0 and 10, where it was a much smaller number gave sort of a negative value. So the scaling, just the scaling of the numbers really changed people's response. So something else to think about. We give this same question about how much TV people watch, or how much more applicable question would be how much screen time do you have? When we give it on this scale from a half hour to more than 2.5 hours, we get very different responses than if we give it on this scale from 2.5 hours to 4.5 hours. And the way people look at a question like this is that they think of the scale, they don't really look at the numbers in the scaling, they look at the range of the scaling, and they might think to themselves, well, I don't watch a lot of TV. I probably watch a little less than average, and they'll pick a response that's a little less than the middle. And when the scale is, I'm going back to the one before, when the scale is like this, they'll probably pick 1 to 1.5 hours. When the scale is like this, they'll pick 3 to 3.5 hours. And just because the scaling is different, not wrong, scaling is different, people pick a different response. So again, the scaling of our questions is vital. And that was just kind of, that slide was just summarizing it. They looked at migraines, and if you ask people about migraines, they'll say many more, or it's worse severity, depending on the scaling. So we asked the question about life satisfaction. And if we ask the question about life satisfaction right after relationship satisfaction, those two items will correlate quite a bit. So I'm thinking about my relationship status and my relationship satisfaction, and then I go into life satisfaction, I'm thinking of the same thing. If I separate those questions by 10 items, they don't relate much at all. So I'm thinking my life satisfaction, I'm not thinking about relationships anymore, I'm thinking about other things. So the question before your question can prime the person to respond differently. So again, it's important the order of our questions, the scaling of our questions, if it's open-ended, if it's closed-ended. The Schwartz article scares me quite a bit in creating self-reports, and my recommendation is don't create a self-report unless you absolutely have to. Look at what already exists, adapt what already exists, and if you have to come up with a measure, use a structure that already exists as much as possible. So that's our lecture on measurement and how it relates to construct validity and how it relates to the other validities.